Mm-hmm.
Number 3 is practice and we play Kahoot. 4 is end the ticket and wrap up class.
Perfect. So, very, very simple today, right? So, like I said, we're getting ready. Oh, wow. Sorry about that date. I didn't even realize that it said that. But it's actually the 26th. But like I was saying, today's class is actually relatively simple, right? We're getting ready for our CFU, like I said, that we're taking on Friday. And since we have been going crazy on that CFU, the biggest thing that we're able to get us ready for that was our preparation. All right, so let's make sure we're continuing to prepare. We're following along, we're participating, we're winning those Kahoots. So that way, when it's time to take our tests on Friday, everybody's getting high grades, okay? So, again, we're making sure that we're earning our 5 PBIS points, get our full complement of PBIS points. And can I have Mr. Justin Wilson tell me, how do we earn our 5 PBIS points? Justin, you there, bro? Going once. Going twice. Going 3 times. Blake, can you tell us, how do we earn our 5 PBIS points? Oh man, Blake got food in his mouth. My bad, bro. I didn't mean to get you like that.
You can earn your 5 PBS points by keep cameras on during class.
Mm-hmm.
By responding to questions in the chat.
Mm-hmm.
And volunteering to respond when
prompted. Mm-hmm.
Complete all classroom assignments.
Perfect. So, like my boy Blake said, make sure our cameras are on, make sure we're participating, let's make sure we're all volunteering, and we're also completing all of our assignments, all right? So, with that being said, let's dive straight in to our vocab check, because vocabulary is what has really been guiding us through our last couple investigations, okay? So our first vocabulary term, which everybody should have in a notebook because we've been talking about this for like 5 weeks now. Can I have Marcus go ahead and tell us, what is density? Got me, bro. Still muted. You gotta press unmute. You might have to go through a Zoom tutorial on unmuting again. Looks like a lot of us are struggling with that a little bit. Well, now it's not working. Okay, no worries. How about, let's see who is here. Mr. Knight, Darius, go ahead and tell us what density is. Darius, can you unmute for me, sir? Come on, guys. Anybody would like to volunteer? Because it looks like mics are not working. All right, go ahead, Marley.
Density is the measurement of how compact the mass of a substance of object is.
Thank you, boss. So, like you said, it is the measurement of how compact the mass or a substance of an object is, right? So when we're talking about density, we're trying to see how compact the mass inside something is, right? And we know how we weigh mass because... Okay, no worries, Darius. I got you. And we know that mass equals weight, right? So when we're trying to see how heavy something is or how dense something is, that is what we're measuring when we're looking at density. Okay? So this was like I said, our leading key vocabulary term. We're actually going to introduce a few more vocab terms that I would like for you guys to put in your notes as well. Okay? So first one is related to energy transfers. Okay? So that first one is radiation. All right, so radiation is energy. Marley, can you mute yourself for me, please? Thank you. So, radiation is energy that is radiated or transmitted through space in the form of rays, waves, or particles. All right? This is one form of energy transfer. We have another form of energy transfer, which is called conduction. This energy transfer is by contact between particles, all right? So like when you rub your hands together or when you're touching other things, that is conduction, okay? But then we have our last one, which is the one that we're actually going to focus on today, which is called convection. All right. So can I have Zamari? Can you read it to us? What does convection mean?
Energy transfer during which high fluid rises, and I can't see the other part.
My bad. Let me move that for you. Can you see now?
No.
Okay, no worries. So it's energy transfer during which hot fluid rises and cold fluid sinks, creating a cycle. Okay? And if you cannot see those, they're actually in the chat for you right now. Mr. Bangor was able to put those in there for you. So we have radiation, which is energy that is radiated or transmitted through space in the form of rays, waves, or particles. We have conduction, which is energy transferred by contact between particles. And then we have convection, which is energy transfers during which hot fluid rises and cold fluid sinks, creating a cycle. Okay, so the one that we've been looking at we've been looking at convection, right? Because we've been studying the way that heat transfers through fluids, right? And we've been checking about the density of it and how it goes up and how it goes down. Okay. So I'm going to put it in the chat for us one more time because the one that we're focusing on is convection. Transfer. Hot fluids rises and cold fluids sink. Okay. So everybody should have that. Okay. Appreciate you, Mr. B. So we'll give us a few more seconds to make sure everyone has that down. So we know the difference between our three types of energy transfer: radiation, conduction, and convection. Like I said, today we're going to focus on convection because that's the one that we've been actually studying the most. But we're actually going to come back to these three different types of energy transfers later throughout the year. Okay, so I just want to introduce us to what the way we transfer energy. Okay, so let's actually take a look at what these type of energy transfers actually looks like. So this right here is an example of a convection. So we're going to actually watch a quick video on convection. So we have hot water poured into the center cup to blow out a heat source, and a basin of room temperature water is placed on the cups. We have ice cubes made with blue water that are added to each side, right? So we know that the blue water and ice cubes, that is typically colder water, right? So as you can see, because it's cold, it is sinking to the bottom, right? So let me pause real quick. So we have the cold ice cubes that are here that sink straight to the bottom because we know that cold air has higher density. So it's heavier, right? So it goes to the bottom. We added in some warm red water, which started off at the bottom, but is now raising because warm air goes up. So we're going to watch as the convection currents mix the water inside, right? So convection currents have formed in the tank. And we're going to take a look and see how it forms. See that warm air going up. And then when it reaches the top where there's the cold ice cubes, it comes back down. I want you guys to put in the chat, right? You said the question says, notice how the ice or the water currents, they go up and sideways rather than just straight up and down. Why do you think it goes up and out? I want you to put it in the chat. Why do you think it goes up and out? Thank you, Darius. I should be seeing some more responses in the chat. Remember, this is how we're getting our PBIS points for today. So I'm looking to see some more responses. Why do we think the water goes up and out? Exactly, right? So we know, like Mr. Bengora said, the hot air and the cold air cycle. We know that the warm air goes up, the cold air goes down. So just keep watching the video and see how it keeps moving, right? So we're looking at the convection current. So we see now that the water is expanding because now it's making the water warm. Exactly. So Justin said that he thinks that it's making like a water wind inside there because it's hot air and cold air mixing, which is true. Since the hot air goes up, the cold air goes down, it pushes back and makes a wind, right? Okay. So when we watched the video, we saw that there was the hot water that was on the bottom, and we added the ice cubes at the top, right? So the cold water, because it's more dense, went to the bottom, right? But then when it went to the bottom, it was then heated, or the energy transfer from the hot cups were able to make that water go back up. So that's why we're able to see the water go up and out, and then back in a circle, continue in its cycle, right? Because that is what convection currents do. And exactly, I love the analogy Mr. Bangora says. He says that the hot air is like chasing the cold air, right? Like it's just going in a circle. So what we know is with kinetic energy, we know that kinetic energy, when it's high, it tries to spread out and find places that have low kinetic energy, right? So basically, we're taking a look at this. Oh. So we're taking a look at this, right? These are the area where there's high kinetic energy. It's all high kinetic energy in here. There's low kinetic energy down here. So it's going up first because it's trying to find where the kinetic energy is low, so that way it can make the air warm, right? It's trying to disperse all of this kinetic energy, right? Because it's bouncing all over the place. It's high. This is slow, so it's trying to speed it up. So it's basically just chasing it in a circle, and that is how we get what we call convection currents. Okay? Anybody have any questions? Najee, you got a question? Oh. All right, no worries. Marcus, you got a question? Who just had their hand up? Somebody had their hand up? Okay, no worries. All right, cool. So we're actually gonna move on. And I'm gonna bring back this old picture that we looked at last time. Okay, so I want everybody in the chat to remind me. Oh, that was Justin. So Justin, you want to ask that question for everybody? Okay. Oh, my bad. Oh. So just ask, why did they go separate ways, right? Why does it disperse out and over, okay? Can anybody answer that question for him? Does anybody else know?